Welcome. In this video, I'm going to show you how to find the derivative of this function here, that is of f of x equals the square root of x when x equals 4. So that is, we'll be finding the slope of the line tangent to this curve f at x equals 4. And we're going to use, again, two different definitions. So first, we're going to begin with f prime of a is equal to the limit as x approaches a of f of x minus f of a divided by x minus a. So f prime of 4 is equal to the limit as x approaches a of the square root of x minus the square root of 4 over x minus 4. So I'm going to rewrite these square roots. And actually, let me fix this. That should not be an a anymore. That should be a 4. So this is the limit of x to the 1/2 power minus 2 over x minus 4 as x approaches 4. So as an aside here, x minus 4 can be written as x to the 1/2 power quantity squared minus 2 squared. And that's on purpose. I want to write this as a difference of squares. Doing so lets me do something really nice here in the denominator. That is, I can rewrite this as the limit as x approaches 4 of x to the 1/2 power minus 2 over x to the 1/2 power minus 2 times x to the 1/2 power plus 2. And again, that's because I took advantage of the fact that a difference of squares, that is a squared minus b squared factors is a plus b times a minus b. Okay, so that said, x to the 1/2 power minus 2 in the numerator and in the denominator match, so they go away. And I end up with the limit as x approaches 4 of 1 over x to the 1/2 power plus 2. Now I can apply direct substitution because I no longer have a 0 in my denominator when I input a 4 in for x. So this becomes 1 over the square root of 4 plus 2, which is just 1 over 2 plus 2, or 1/4. So this tells me that the derivative of f with x equals 4 is 1 over 4. Now let's do this again with the second definition, that is f prime of a equals the limit as h approaches 0 of f of a plus h minus f of a over h. So f prime of 4 is equal to the limit as h approaches 0 of the square root of a plus, not a, four plus h minus the square root of 4 over h. So this is the limit as h approaches 0 of the square root of 4 plus h minus 2 over h. And I'm going to multiply both the numerator and the denominator by the conjugate here. That is the conjugate of the numerator. So I'm going to multiply by 4 plus h inside the square root plus 2 on the top and the same quantity on the bottom. In my numerator, I'll end up with the limit, in my numerator, I'll end up with 4 plus h minus 4 divided by, in my denominator, h square root of 4 plus h plus 2. And I would resist the temptation to simplify this and multiply that out. Just hang tight. You'll see that that'll go away really nicely. So this is the limit as h approaches 0. And let's talk about what's going on in the numerator really quickly. We have 4 plus h minus 4. That's just h. So in my numerator, I have h. And in my denominator, I have h times the square root of 4 plus h plus 2. H divided by h is just 1. So I have the limit as h approaches 0 of 1 over the square root of 4 plus h plus 2. Now I can go ahead and apply direct substitution to get the square root of 4 plus 0 plus 2, which clearly is just going to give us 1 over 2 plus 2, or 1 over 4. So again, applying a different definition, I still get f prime of 4 equals 1/4. I hope this video was helpful.